Hello everyone, I hope you guys are having a great day. This is our presentation on our ENGR 241 data science project. I am Anthony Caligari and I'm an electrical engineering and this is my third year. So as a quick introduction to our dataset, we use the car details dataset and all of the data in this specific dataset was taken from previously owned and used cars. There were some that were first owned or second owned, but they were still used. And in particular, it covered the car make, the car model, and it also covered the kilometers already driven on the car, power and brake horsepower, which is bhp, and fuel tank capacity. In addition to these, it also included other statistics like torque, the number of seats, drivetrain, which is all-wheel drive or full-wheel drive, and the dimensions of the car, also like the color, but we didn't include them in the scope of this project, even though they could be deemed as important. And our goal for this project was to explore the relationship between price and how it correlated to these different elements above. These are our histograms. We did 3 of them. For figure 1, it showed the frequency of automatic cars over the years. This histogram logically makes sense because more recent car models have become automatic over the time instead of being manual. Figure 2 shows the frequency of cars being above 900,000. We think the currency was in rupees, but we're not 100% sure. This histogram also makes sense because over time, cars have gotten more expensive. And then figure 3 shows how many cars had a fuel capacity over 45. The importance of looking at all 3 of these histograms was to compare them to see how price rose with the different elements of the car. As more cars became automatic and have had higher fuel capacity, the price has also increased.
All right. Hello, my name is Jagan Robinson. I'm an electrical engineer. I'm in my third year, and I'm going to be presenting the next few parts of this presentation. So yeah, we're gonna move on to the descriptive data from the histograms. So for these, the very first data shows statistics on the amount of automatic cars sold. It has a count of 926, a mean of 2017, deviation of 3, and shows a range from 1988 to 2022. For the second one, it shows detailed statistics from like the second histogram, the number of expensive cars sold. It has a count of 954, so 954 items. A range from 1988 2022, and a very similar mean to the first one. And then for the third one, it has a way larger count of 1,182, showing a mean very similar to the other ones of 2016.9, deviation of about 3, and the same range from 1988 and 2022. And it also shows the statistics of the high capacity cars sold. Now moving on to the scatter plots. So for this very first scatter plot, it's showing the relationship between the price of cars and the relative max power of the cars. And we only chose cars that had a 6,000 RPM just for simplification purposes. And it shows that like most of the data is like contained between 0 and 1 times 10 to the e times 10 to the 7th rupees in terms of price, and like between 300 to 100 BHP at 6,000 RPM, and that shows like a main condense of the data, like, and as like a general relationship, as the price increases, the power of the car increases, which relatively makes sense if you want to think like the quality of the car should increase with the price, so the power should increase with the price. And then for the second scatter plot, it shows scatter plot between the price of the cars and then the types of engines of the car, which we can't really get a solid relationship. So we used this form of data as a showing of, just as an example of data that may not have to have like a specific conclusion.
Hi, my name is Justin Fan, and I'm a third year software engineering student at Stevens. So for our linear regression modeling, we first selected the car's extracted power to use as the independent variable, and we found the f-stat value to be 3063 and the p-value to be less than 0.001, which shows that the car's extracted power is statistically significant in evaluating, or in the outcome of the car prices. And the t-stat value is 55.346, which only supports that case even more. And for our multilinear regression modeling, we also selected the car kilometer to use as another independent variable. And from this, we found that the f-stat value is 1616 and the r-squared value is 0.636, which has increased from 0.624, which shows that the car kilometer also plays more of a role in the prices of the cars. And from the multilinear regression model, we found that the t value for the car extracted power increased to 56.010, and the t-stat value of the car details kilometer is negative 8.028. So these models show that the extracted power and kilometers are statistically significant in playing a role affecting the prices of cars. So for our ANOVA table, we have selected 3 elements to measure their variability in the prices of cars, and the 3 factors we chose are transmission make and year. And these elements, we can see that they have large f-stat values and very, very small p values, which shows that these elements are statistically significant in the prices of the cars. Alright, and that concludes our presentation. Thank you for watching.